All right, we're going to go over some of these problems from page E of the AP Prep Geometry Summer Homework. This one is about the Pythagorean Theorem. So Pythagorean Theorem applies to right triangles. Anytime you have a right triangle, the side lengths will always follow this relationship. The two legs of the right triangle, they're next to the right angle. We'll call those A and B. Those are kind of interchangeable. C is the hypotenuse. That's the one that's important. The hypotenuse always has to be C. It's always the longest side, right? These two legs, doesn't matter. They're kind of interchangeable. Doesn't matter which one we call A or B. So they always have the relationship that A squared plus B squared is equal to C squared. And so we can use this for a lot of different things. If you know two of the sides, you can always use the Pythagorean theorem to solve for the third side. Also, if you just know the sides of a given triangle, you can substitute those numbers, side lengths of a given triangle, you can substitute those numbers in here, and if we end up with a true relationship, if the sum of the two sides squared is equal to the longest side squared, then we also know that that triangle has to be a right triangle without even actually being able to measure a 90-degree angle. So what we're going to do is we're going to kind of use that idea. We're going to use these side lengths to try to decide if these would create a right triangle. All right, so I'm going to go ahead and look at this first one here. We have three side lengths. Now again, remember I said that A and B can be interchangeable. The one that's important is C. C has to be the longest one. So in this case, this would have to be the hypotenuse. So what we're going to be doing is we're going to be checking whether 5 squared plus 8 squared, if that's going to be equal to 9 squared. If this is a true relationship, then it's a right triangle. If not, it's not a right triangle, it's something else. So we have 25 plus 64 equals 81. I don't think this one's going to work. When I add those together, I get 89 equals 81. So in this case, this is not a right triangle. And we know that because that relationship was not true. It was not an equal relationship. All right, let's go ahead and try one of these other ones. Let's go ahead and try C. So we're given these three side lengths. We have 3, 3, and the square root of 18. Now, with these problems, it might be difficult to determine if this number is the biggest side or not. But in this case, we do know it's the biggest side because, well, these are 3, and the square root of 18, 18 is bigger than 16, which we know the square root of 16 to be 4. So this is going to be a little bigger than 4, which is obviously bigger than 3. So let's go ahead and substitute these numbers in. 3 squared plus 3 squared. Let's see if that's equal to the square root of 18 squared. Parentheses around that, why not? All right, so 3 squared is 9. So this is 9 plus 9. Square root of 18 squared is actually just 18. The square root and the squaring kind of cancel each other out. And yeah, this is going to work. 18 is equal to 18. So this one is yes. This one is a right triangle. You can even check mark it maybe. So that's pretty much it. If the three side lengths do satisfy the Pythagorean theorem, then we have a right triangle. If not, no. All right, now with these problems, we're doing still using the Pythagorean theorem, but we're going to be starting with two known side lengths and figuring out the third. There's really two types of these problems. Either you're missing C, the hypotenuse, or you're missing one of the legs, A or B. It doesn't really matter. It's going to be basically the same. Again, remember C has to be the hypotenuse. That's kind of the one that matters in terms of where we put it. All right, so let's go ahead and we will do B, and we'll do one of these with a radical. We will do, I don't know why not. Let's do B and C. So in this case, we do not know A. We do know B, and we do know C. So we evaluate that a little bit. A squared plus, this is 225. This is 289. Then we're going to subtract 225 from both sides. It's going to give us that a squared is equal to 64. And that's a nice perfect square number. So when we go to take the square root of both sides, figure out that a should be 8. Cool. So in this case, a is 8. That is a Pythagorean triple. There's a lot of common Pythagorean triples. 3, 4, 5, 6, 8, 10, 5, 12, 13. We're going to see those a lot. They're really nice, but there's not that many of them. We call it a Pythagorean triple because all of the side lengths are whole numbers. No radicals, no decimals, nothing like that. All right, and here we go. We'll do this next one. So this one was important. We were solving for a leg, right? And so you need to be careful there. It's more of a solving or calculating or subtracting from both sides, taking the square root. It's a little different than when you're solving for C, which is this next one. All right, so this next one we've got 6 squared little plus 6 root 3 squared equals C squared. That's what we're looking for. This one, you'll notice a little different. All of our numbers are here on the same side of the equation. So we're going to be able to put that all together and then take the square root. 6 squared is 36. This is a little tricky. I'm going to kind of break this up and show what's going on here. Multiplying, essentially, right, 6 root 3 times 6 root 3. Well, 6 times 6 is going to give us, right, with these two, we're going to get 36. And then with the radicals, the square root of 3 times the square root of 3, that's going to give us 3. And then we can kind of multiply those two things together. We end up with, well, 36 times 3, 108. So 36 plus 108 equals C squared. Those are going to add together, and we're going to get 144, which again is a nice perfect square number. So when we go ahead and try to solve that, we actually get 12. That C is 12. So again, these are kind of the two types of problems that we'll use the Pythagorean theorem with to solve for a side. You'll either be solving for a leg, like this one where we solve for A, or we'll be solving for the hypotenuse, like this one. Some tricky things can happen with the radicals. You know, take your time, break them up, use as many steps as you can. You can also use a calculator, but it would be nice to know how to do this by hand.